here was the bell work. We know that for number one, we use right triangle trigonometry when we have a right triangle, and we use SOHCAHTOA. And then number two, write a paragraph explaining when you would use the law of sines. That would be if it's an oblique triangle and you have angle, angle, side, angle, or side, side, angle. And we use the law of cosines if it's side, angle, side, and side, side, side. We're going to review for the test now. So the worksheet with the triangles, the law of sines and law of cosines due today. So some of you turned it in already. The rest of you need to turn it in if you haven't. And the review paper is due next time, although you probably should have had it done this time. Okay, we're going to review for the test right now. So we're changing 58.34 degrees to degrees, minutes, seconds. Write it down. Show me what you have. Remember, if you need to write something on your 3x5 card, now would be a good time. If you need to make one and cut it out. Some of you put it in your calculator. You typed in 58.34. And then you went to the angle menu, second naps. And then number 4 is DMS. And 58 degrees, 20 minutes, 24 seconds. Or the other way you could do it, you guys, is take the decimal, 0.34, and go 0.34 times 60. And you get 20.4. The 20 is the minutes. And then you take the 0.4 and times that by 60. And there's the seconds. So 58 degrees, 20 minutes, 24 seconds. So you can do it that way. Any questions on how to change degrees, minutes, seconds? Okay, every problem I show you today is going to be like one on the test. I showed you some last time as well. So, okay, next problem. Let's say you have 143 degrees, 21 minutes, and 48 seconds. I want you to change that to decimal degrees. Change that to decimal degrees. On this one, you guys, you're just going to take the 143 and you're going to add to it 21, the minutes, divided by 60, because there's 60 minutes in a degree. Oh, whoops, I didn't mean to do that. 143 plus 21 divided by 60 plus 48 divided by what? 3,600. Yeah, don't forget it's 3,600, which is 143.363. Any questions there? Okay, there's one like that on the test. Okay, next question. Okay, I want you guys to find an angle that is, I want you to find the least positive angle that's coterminal to negative 1,072 degrees. So it's going to be a positive angle, and it's going to be the smallest positive angle that's coterminal to that one. So what are you going to do to find the answer to this one? You're going to add 360 until you get a positive number. That's all you're going to do. And that number is going to be between 0 and 360. So what was the answer? 8 degrees. If you just keep on adding 360 to negative 1,072, just put in negative 1,072 and add 360 until you get a positive number. That's all you do. Okay? All right, what if my angle was 1,505 degrees? Find an angle, the least positive angle coterminal to that one. The least positive angle coterminal to 1,505. Okay, did everybody just add or minus 360 from 1,505 till you got the smallest positive number? And what did you guys get? 65 degrees. Okay, good job. Okay, next problem. I want you to find the sine, cosine, and tangent for angle A. Sine, cosine, and tangent. Sine, cosine, and tangent of A equals what? Sine, cosine, and tangent of A. Go. You guys, if you use the Pythagorean theorem, what'd you find out this side to be? 16, right? And then the sine is equal to opposite, which is 16 from A. Opposite from A is 16 over hypotenuse, 16 over 20, which reduces to what? 4/5, right? 4/5. And then cosine was equal to adjacent, which is 12, over hypotenuse, which is 20. 12 over 20, which reduces to 3/5. And then the tangent was opposite over adjacent, 16 over 12, which reduces to 4/3, right? Any questions on that? Right triangle trigonometry. Okay, next one. If the sine of theta equals 5 over 13, find the tangent of theta. Give you a second to think about that one. Okay, so on this one, we have, if you made a triangle, you guys, I always like to draw a picture, especially if you're struggling with this, and put the angle theta in it somewhere. And you know that the sine is defined to be opposite side over hypotenuse side. So we can just, from that angle theta, we go, the opposite side is 5, and the hypotenuse is 13. Obviously, I did not draw this to scale, did I? So don't get caught up in that. I just drew a triangle, a right triangle, okay? And then, since I'm looking for the tangent, tangent's equal to opposite over adjacent. But I need to know what that adjacent side is, so I do the Pythagorean theorem. What'd you guys get? 12, okay? And so opposite side would be 5, adjacent side would be 12, and so my answer is 5/12. That's all you do, okay? Any questions there? Okay, you guys seem to get this down. Okay, here we go. Let's do this one. Let's say that I have a point that the terminal side of an angle goes through. Let's call it -5, comma, -12. And I want to find an angle. I want to find the sine of an angle. I want you guys to find the sine of an angle theta, such that the terminal side of the angle goes through the point -5, comma, -12. Find the sine of an angle theta such that the terminal side of the angle goes through -5, comma, -12. Okay, you guys, so on this one right here, if you graph the point -5 and -12, you're going to go to the left 5 and down 12. So -5, comma, -12, we're down in the third quadrant. We draw a line to it. And you guys, this would actually work either way, but you should always draw the line to the x-axis. So your triangle is that portion right there. Because you're going to go over -5, you're going to go down -12. And then if you use the Pythagorean theorem, you find out that that side's 13, right? And we're supposed to find the sine. So sine, and theta is always the angle by 0, comma, 0. Sine is equal to opposite over hypotenuse, so the opposite side is -12. The hypotenuse is 13, and so my answer is -12/13. Any questions? You guys got this down. Good job. All right. Okay, next question. Let's say I have a triangle R, Q, Z, and you know that this angle, or this side right here, is 17 inches. And you know this side right here is 23 inches. And you want to know the measure of angle R. Find the measure of angle R. What'd you guys get again? 32.4. Is this what you did? Since we're trying to find angle R down here, and we have the adjacent side and we have the hypotenuse side, that's a cosine of R equals adjacent over hypotenuse, right? And then you did the cosine inverse of 17 over 23. Anytime you're looking for an angle, you're doing the inverse. Is that what you did? And tell me the angle one more time. Degrees. Everybody agree with that? Okay. Okay. We're going to evaluate this expression right here. Let's say I have something like the sine of the arc tangent of root 2 over 5, and I want to evaluate that. I want to get exact value, so you can't use your calculator for this. I want you to set up a triangle and solve it. Okay, so we use this right here to set up the triangle. We assume it's in the first quadrant. Here's theta. We know that can be written as tangent of theta equals square root of 2 over 5. And we know that tangent's equal to y over x. So y must be square root of 2, and x must be 5, right? X is the horizontal distance, y is the vertical distance. Okay, so to find the hypotenuse, I go 5 squared is 25, square root of 2 squared is 2, and that gives me r squared, which is 27 equals r squared, which is r equals root 27. But root 27 simplifies, doesn't it? Okay, yeah, well, we know that 27 breaks down into 3 times 9, and 9 breaks down into 3 times 3, and we have a pair of 3s and a loner 3, right? The pair of 3s makes 3, and the loner 3 goes back inside the square root. So this is 3 root 3, right? What is 25? Okay, so we have 3 root 3. Now, sine, because we're really looking for a sine, right? The sine of theta is equal to opposite side, which is root 2, over hypotenuse, which is 3 root 3. But what's the problem with that answer? You've got to rationalize the denominator. How do you do that? Times the top and bottom by root 3, right? So root 2 times root 3 is root 6. And square root of 3 times square root of 3 is 3, and 3 times 3 is 9. So your answer is square root of 6 over 9. There's going to be one similar to it on the test, so you know. Okay? All right. Okay. Okay, next problem. So what if I said the sine of x equals square root 2 over 2, and I want you guys to find all the answers between 0 and 360 degrees. You don't need a calculator. You need your unit circle for this. See if you can find all the answers. Okay, so sine is defined to be the y coordinate on the unit circle. So we find the unit circles with a negative root 2 over 2. That would be at 315 degrees and 225 degrees have y values of negative root 2 over 2. Okay? All right. Hey, just before we take the test here, you guys, I want to talk about, I didn't go over any more about right triangle trigonometry, but if you're going to solve a triangle or any part of a triangle, if it's a right triangle, what are you going to use? SOHCAHTOA. Okay, use right triangle trigonometry, SOHCAHTOA. If it's not a right triangle, what are you going to use? Law of sines and law of cosines, depending on if you have two things that are opposite, like an angle and a side that's opposite, I'd use law of sines. Otherwise, I'd use law of cosines. Okay, but I told you today for the bell work, side angle side and side 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 are law of cosines, right? Side angle side and side side side. Okay, we're going to take the test now.